This is sections 8.5 and 8.6 on trigonometric ratios. The word trigonometry comes from the ancient Greek words that mean triangle measurement. So what the study of trigonometry, which is really a branch of geometry, what that does is tries to measure triangles. When you know some pieces, what can you say about the measures of other pieces? When you know an angle, what can you say about the sides? When you know the sides, what can you say about the angles? We will be limited in this course to the trigonometry of just right triangles. We will be just looking at the measures of the right triangles. And in a trigonometry course or pre-calculus course, you will be getting into how to apply trigonometry to any triangles. So, trigonometry works with ratios. And with this right triangle I've drawn here, let's say I've got my angle A there. The first trigonometric ratio that we're going to look at is called the tangent. The tangent is just a ratio, which means it's going to be, in this case, a fraction of two sides of the triangle. Specifically, the tangent of A is the leg opposite angle A divided by the leg adjacent to angle A. So we know all right triangles have two legs and then the hypotenuse. While the leg opposite angle A is the one all the way on the other side. So this is opposite angle A. The leg adjacent to angle A is the one next to it, which is this one. Okay, so when I want to find the tangent ratio for angle A, I take the value, the size, the length of the side opposite angle A, and put that in the top of my fraction, and I put the length of the side adjacent to angle A in the bottom of my fraction. And that's all it is. So for example, I've got a right triangle here with legs 5 and 12 and hypotenuse 13. I'm asked to find the tangent of angle F and the tangent of angle G. So tangent, notice, is often abbreviated TAN. So if I want to find the tangent of angle F, the tangent of angle F equals, it's a fraction, it's a ratio of the leg opposite angle F. So I'm going to write that out. Opposite over adjacent. So what leg is opposite angle F? 12. What leg is adjacent to angle F? 5. And that's it. That is the tangent of angle F, 12 over 5. Or 2 2/5. But 12 over 5 is fine. That's a simplified fraction. Okay, what's the tangent of angle G? Well, again, tangent is opposite over adjacent. Which leg is opposite angle G? Angle G is up here. Opposite it is the 5. So that goes on the top. What leg is adjacent to angle G? Well, what's next to angle G that's a leg? That's 12. And that goes on the bottom. Notice for the two acute angles of the right triangle, the tangents are simply reciprocals of each other. One of them is 12 over 5, the other one is 5 over 12. Makes sense because they're both working with the same two legs. They're just flipped. So that's how we find the tangent ratio of an angle. Now why is this useful? Why do we care about tangent ratios? Consider these two right triangles. Notice that in addition to the two right angles, angle C and angle T, which are definitely congruent because they're both 90 degrees, we also have another pair of congruent angles because angle A is congruent to angle R. So that means triangle ABC is what to triangle RST? What do we call it when two triangles have two angles that are congruent? We say those triangles are similar. Very good. Alright. So, we've got two similar triangles by angle similarity. What's true about the sides of similar triangles? They're in proportion. Okay. So, we could say A, side A, over R equals B over S, because corresponding sides of similar triangles are in proportion. Okay? But I can cross multiply. Multiply both sides by R and divide both sides by B, and I could rearrange it as A over B equals R over S. That's valid. It's a property of proportions. I'd be multiplying both sides by R and dividing both sides by B. And I end up with that. But A over B is the same thing as the tangent of angle A. Because A is opposite angle A, B is adjacent to angle A. And R over S is the same thing as the tangent of angle R. Because little r is opposite angle R, and S is adjacent to angle R. So that means that if angle A is congruent to angle R, then the tangent of angle A equals the tangent of angle R. If two angles are congruent, their tangents are equal. Their tangent ratios are equal. So in other words, the value of the tangent of an angle depends only on the size of the angle, not on the size of the right triangle. So no matter what triangle the angle is in, as long as it's a right triangle, the value of the tangent for that angle will always be the same. The fact that it will always be the same, if I have a 30-degree angle, its tangent is always going to be the exact same value, no matter which right triangle that 30-degree angle is in. The fact that that is always the same means that we can find sides of right triangles if we have the angles. For example, let's find the value of x to the nearest tenth. So we're going to round it to 1 decimal point. Tenth is 1 decimal point. Well, we've got an angle, the angle 56. How would we write the tangent of 56 degrees here? Well, what side is opposite 56? That's x. What side is adjacent to it? That's 32. Okay? So the tangent of 56 equals x over 32. How do I solve this for x? I would need to multiply both sides by 32. So x would then equal 32 times the tangent of 56 degrees. Now we can actually find the tangent of 56 degrees. A simple calculator will do that for us. Notice the tangent button right here in orange. So I'm just going to put in 56, say I want the tangent. And it tells me it's this really long decimal. In fact, it's a non-repeating, non-ending decimal. But I'm going to take that and I'm going to multiply it by 32. And I get about 47.4. I want to round it to 1 decimal place, so it's 47.4. X equals 47.4. Because I found the tangent of 56 and multiplied it by 32, so that gave me 47.4. If we need to find an angle instead of a side, we can use a function on our calculators that's called the inverse tangent. which will usually look on a calculator like this. Tangent to this little -1 exponent. It's not an exponent, it's just notation, just a symbol to imply that we're finding the inverse tangent instead of the tangent. So what the inverse tangent does is, given the tangent ratio, find the angle that has that ratio. That's what the inverse tangent can do for us. So for example, let's find the value of x in this triangle. X is a number of degrees. That is the measure of this angle in the bottom left of our triangle. And I happen to know both legs of this right triangle, the leg opposite it and the leg adjacent to it. So that gives me enough information to be able to apply the tangent. Because the tangent of x degrees is going to be 12 over 100. Okay? 12 over 100 as a decimal is the same as 0.12, 0.12. So if I want to find x, I'm going to take the tangent inverse of the ratio of 0.12, and that's going to give me x. Now, not all calculators have a tangent inverse button. I'll show you in class another way that you can find this if you don't happen to have a calculator with the tangent inverse option. But here I've got one. So I'm going to put in 0.12, and I'm going to take the inverse tangent. So I see this little tan inverse option there. I'm going to click that, and it tells me it is about 6.8428. Again, that's an approximation, but if we round it to say 1 decimal point, we'll get that x equals, x is approximately, instead of actually putting equals, we should put this squiggle equals, which means approximately 6.4. In this case, degrees, because x was an angle. We'll be doing a bunch of examples like this in class, so don't worry if it's kind of confusing right now. Two other common trigonometric ratios are the sine ratio and the cosine ratio. So again, let's think of this right triangle with angle A here. We know this is the leg opposite angle A. This is the leg adjacent to angle A. And what do we call this thing up here? We know we call that the hypotenuse because it is opposite the right angle. So the sine of angle A uses one of the legs and the hypotenuse. So which leg does it use? The sine uses the leg opposite angle A. So the sine of angle A is the leg opposite angle A divided by the hypotenuse. Instead of dividing by the leg adjacent to it, we're going to divide by the hypotenuse. Similarly, the cosine of angle A is the leg adjacent to angle A divided by the hypotenuse. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. As a way to summarize those three trigonometric ratios, use this abbreviation. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. SineCosine. Just remember SineCosine, and you'll remember the three main trigonometric ratios: sine, cosine, and tangent. SineCosine. SineCosine. You will want to memorize that. One quick example of the sine and the cosine. Find the values of x and y to the nearest integer. So we're going to have to round to the nearest whole number, the nearest integer. So let's find, say, x. Well, x is the leg opposite the angle that we know. We know the angle at 67 degrees. X is the leg that's opposite it. So which ratio uses opposite? That's the sine. We're going to take the sine of 67 degrees. That's going to be the leg opposite 67, which is x, divided by the hypotenuse, which is 120. I'm using sine here and not tangent because I don't know either one of the legs. So I'd have two variables if I use tangent. Using sine, I just involve one variable. And again, if I want to find x, I need to multiply both sides by 120. So it's going to be 120 times the sine of 67 degrees. So what is the sine of 67 degrees? 67 sine, it's that long decimal, and I'm going to multiply it by 120, and I get about 110.46. So if I'm going to approximate that to the nearest integer, it's approximately 110. Technically, if we were rounding it, the 6 would make the 4 into a 5, and that 5 would make the 0 into a 1. So we could say x is approximately 111. And we're going to find y in the same way, except y is the leg adjacent to 67. So it's going to require using the cosine. The cosine of 67 degrees is the leg adjacent to it, which is y, divided by the hypotenuse, which is 120. So y is 120 times the cosine of 67 degrees if I just multiply both sides by 120. So I'm going to find the cosine of 67 degrees. 67 cosine equals, that's not correct, 67 cosine and times 120 equals about 46.88, which is approximately 47. Again, we're going to be doing a bunch of examples like this in class. I just want you to be exposed to it right now. Here are your immediate practice problems, which do not require finding values of x and y and going to a calculator. This will not require a calculator at all. You do need to draw the picture. And all I'm asking you to do here is find the ratio of each trigonometric expression. You're just going to write a fraction, and that's it. So find the ratio that represents the tangent of angle B, which would be the opposite leg over the adjacent leg. Find the ratio that represents the sine of angle A, which would be the opposite leg over the hypotenuse. And find the ratio which represents the cosine of angle B, which would be the adjacent leg over the hypotenuse. Just write those three fractions. And that is the end of sections 8.5 and 8.6.